math. The mass of one slug, this is example 7. Yeah, I didn't really know much about a slug before either, but looking it up, 32.17. Makes sense. A slug is defined as the mass that is accelerated by 1 feet per second squared when a force of 1 pound is exerted on it. So it makes sense. Correlation. All right, so when it says mass is 1, that's easy. The spring constant is 5. They're just literally laying out the coefficients. The velocity is 5 feet per second downward. Remember, going down is positive, so this is whoopsie daisy. The initial velocity, it's released 1 foot below the equilibrium. The dampening force is 2 times the velocity. And we're ready to write our equation. All right, so we have our differential equation. We'll need to solve the right-hand side, left-hand side. So it's going to be end up working out to be -2 plus or minus 4i over 2, r equals -1 plus minus 2i. You can verify that on your own. That means a is -1 and b is 2. Therefore, our complementary equation, xc of t, is going to be c1e to the negative t cosine 2t plus c2e to the negative t sine 2t. Because that is case 3, right? Imaginary solutions. Now we write our particular solution, xp of t. And we wanted to make sure it's unique from this, and it is unique right now. So this function is unique from this because we have an exponential on here. So we don't need to doctor up this anymore. Xp of t is going to be a cosine 2t plus b sine 2t. And the first thing we do from there is start taking derivatives. So cosine turns to sine. Cosine. And then they switch back on the second derivative. So -4a cosine 2t minus 4b sine 2t. So we have that. All right, let's keep it moving here. So next thing we're going to do is plug our p of t, xp of t, into our differential equation, match up, and solve. So let's do that next. So -4a cosine 2t minus 4b sine 2t, plugging in, plus 2 times this is going to be -4a sine 2t. 2 times 2b would be 4b cosine 2t, plus 5 times a, or xp of t, a cosine 2t plus b sine 2t. Kind of moving through this since we've seen enough of these examples now. That's going to be equal to that, which is going to be 12 cosine 2t plus 3 sine 2t. That's a cosine 2t there. I'll clean it up here in the next step. So we're looking for like terms. So let's look for cosines. 5a minus 4a is 1a. So I'm going to have 1a and then 4b cosine 2t. Look for the sines, sine, sine, and sine. So 5b minus 4b is 1b. And then we have the -4a. We match those up with 12 cosine 2t plus 3 sine 2t. A plus 4b equals 12. negative 4a plus b equals 3. All right, so just multiplying this equation by by positive 4, we're going to get 4a plus 16b equals 48. That's 17b equals 51. B equals 3. Plugging it back in over here. A plus 12 equals 12. A equals 0. So that tells us our xp of t equation is just going to be 3 sine 2t added to the end of our xc of t. So now we can write our function. X of t equals c1 e the negative t cosine 2t plus c2 e the negative t sine 2t, and then plus 3 sine 2t. That's our xp of t. It was a cosine 2t, a was 0, b was 3. So there's our equation. Now we got to find c1 and c2 using our initial value, but before we can do that, we have to have a derivative. So I like taking the derivative like this. c1, well, we're taking the derivative of e to the negative t, we're going to get a negative e to the negative t cosine 2t. Cosine turns a negative sign, you get a negative 2. So negative 2e to the negative t sine 2t. Ooh, I got that small right there. Probably shouldn't put the parenthesis first next time. Same thing here. Negative e to the negative t sine 2t. Take the derivative of sine 2t, we get a cosine, we get a 2 out. So plus 2e to the negative t cosine 2t. Sine goes to cosine, 2 comes out, plus 6 cosine 2t. All right, initial value. So again, 1 foot down. We're initially displaced 1 foot down, and our initial velocity was 5. So plugging this in, 1 equals c1. This is going to be 1 because you're plugging in 0. This is going away, that's going away. So it's just c1 is 1. That was easy. 5 equals, now this is the second derivative, so now plugging in 5. This is going to be c1 negative 1 from there, because that's going to turn into 1. That's going to go to 0, so I'll put a plus 0 there. Plus c2. This is going to go to 0. That's going to go to 1. And then the 6 will stick around and go to 1. So solving this equation, c1 is 1. You're going to get negative 1 plus 6, which is 5. So this is going to be 5 equals 5 plus 2c2. And that's going to go to 0, equals 0. 2c2 equals 0. That means c2 is 0. So I think we're ready to write our final answer. And I just kind of move this up a little bit. So now we know c1 is 1, c2 is 0. Going back to our original equation, x of t, c1 is 1, so that's going to be e to the negative t cosine 2t. c2 is 0, that's going away. This is going to stick around. And that's your final answer. So I hope you enjoyed the video. The last thing I want to show you is I was trying to find the textbook that these problems came from, and I was able to do that and download the textbook, which I thought was pretty cool. The last thing I found in the textbook with this solution is the talk about graphing transient solutions and steady state solutions. And those weren't in the notes at all. But I just wanted to go over those words. They were new to me, and as I'm taking over, I just wanted to give you some information. So that's what the graphs look like. Here's your xc of t, what ended up working out, and we have our graph. The transient solution is actually down here. The steady state solution is in blue, which is the xp of t. So I thought that was interesting. I'm going to try to find out more about this information, but it makes sense. this would be the normal graph, and then with the dampening force, we're getting closer and closer to 0. So, I hope you enjoyed the video. You guys take care. E Hoodie Math out.